Hey, what's up everybody? It's Zelda and you are listening to the CloudNative.fm podcast, hosted by Cloud Native Islamabad. I'm excited and thrilled to host this show for you. This is episode number 6 of CloudNative.fm podcast. Today is March the 31st, 2021, and in this episode we dive into how to manage and deploy Ingress in Kubernetes with my guest Jerome Petazzoni. And today he promised to share his container and Kubernetes journey with us, and most importantly with time travel update, rewind the clock to understand why Docker is so successful when building an image and run it inside a container. And once container is up, now it works on all the machines and all the environment, and how Kubernetes make it so easy to run it in a production environment. So let me introduce my guest, Jerome Petazzoni. He currently lives in Berlin. Jerome was part of the team that built, scaled and operated the dotCloud platform as a service before it became Docker. He worked 7 years at the famous container company, wearing various hats. When he's not busy with computers, he collects musical instruments and he can arguably play the theme of Zelda on a dozen of them. Want to see what he is up to? Searching on Twitter via JPETAZZO. So let's go ahead and say hi to Jerome and get it over to the internet. Thank you very much, Jerome Petazzoni, for joining me tonight in CloudNative.fm podcast. This is episode number 6, and tonight we dive into what is Ingress, or what are the best use cases to run Ingress controller inside Kubernetes, and how these different tools like Traefik or Nginx or Project Control are fitted into the Kubernetes ecosystem. But let's first, Jerome is joined the Docker so early in the beginning when the company calls dotCloud and when the containers are even a thing. And I'm really excited that I've found a person that know everything around Docker, Kubernetes, and these kind of stuff. Thank you, Jerome, for joining me. Can you introduce yourself to our audience?
Sure. Hi. Well, thanks for having me. I'm really glad and honored to be there today. So who am I briefly? Well, as you can maybe guess from my accent, I'm French. So I spent maybe the first decade of my career working in France, in Paris, for various companies, often around the themes of infrastructure and open source. And then eventually, one day, I got this call from this guy with whom I had worked a few years before, asking me, "Hey, this is Solomon. I don't know if you remember me." "Yeah, of course I do. And you know that dotCloud project that we've been working on? Well, we just raised some money, and long story short, would you like to work in California?" And that was a pretty easy decision for me because I liked the project, I liked the team. Also, my partner back then was living in Los Angeles. I was in Paris, so you can imagine the distance. So moving to San Francisco was definitely an improvement. And I had never had the opportunity before to live and work abroad. So that was like, okay, green lights all the way. And so about maybe 6 months later, I was in San Francisco joining dotCloud. So then fast forward a few years, we rewrite our container engine, we rewrite it in Go, we call it Docker. Solomon announces it at PyCon, and then you kind of know the rest of the story, I'm sure. So after that, I had different roles at dotCloud and then Docker. I started taking care of infrastructure. When I joined, I was basically in charge of our fleet of EC2 instances, load balancers, etc. Then I was managing our SRE team. And then when we did the move to Docker, that's when I became, I like to say, an accidental evangelist, because I started giving talks at conferences, and coincidence, Docker was getting popular. And so more and more conferences and more folks wanted to learn about Docker. So of course, I quickly, as we say, starting living out of a suitcase in airports, going from conference to conference. So that has been my life for a few years. And then starting 2016, 2017, I started to have some health issues, like mental health issues. I was starting being depressed. And I at first, I really didn't understand what was going on because everything seemed fine in my life overall. And I eventually realized I was dealing with burnout. And so after a pretty long process, trying to really understand what was going on, I took the decision to quit the company. And that happened in early 2018. So I took most of 2018 off to kind of rest and think about what to do next. And then I started doing training and consulting on Docker and Kubernetes. So I've been doing that since then. Like, I had a really great year doing that in 2019, traveling, well, maybe not all over the world, but at least in Europe and Northern America. And of course, in 2020, travel suddenly came out of fashion. So I moved all my training online. So since then, I've been doing essentially the same thing, except that instead of traveling to my customers and teach a class in person, we do that online. And of course, the whole pandemic is a pretty horrible thing, and it's been very hard for lots of people. But at least for the work I do, I think it's great that we start thinking about remote teaching that way, because personally, I think it's a little bit silly to gather, the whole engineering team in a classroom for 3 days. You fly in someone, the teacher, and so you try to pack everything in 3 days, and you have this really intense course, and everybody is on that for 3 days until they have their brains melting out of their ears. And now that we're doing that online, we don't need to pack everything in 3 days. Instead, we're like, hey, you know what? We're going to have class, training every morning. And then during the afternoon, you can go back to your regular work. If you are on call or managing some infrastructure, you can take care of that. If there was an outage, an alert, or whatever, you can deal with it the afternoon. And you also have some time to experiment and to play with what we discussed in class the morning. And we can do that over a whole week or even longer if needs be. And I think that makes a lot of sense. Of course, I miss actually traveling, seeing people, and having all these human interactions. But from a teaching perspective, I think that's better. And I hope that, first, I hope that we will be able to go back to normal, hopefully by the end of this year. But also, I hope that we will be able to keep some of the positive things, like, for instance, realizing that if you want a really good training, you don't need to fly somebody in and have this super intense week or super intense 3 days, but we can do that in a better way.
Yes, definitely, because I think Docker is the first one that it came up the idea of doing a Docker gone virtually. I think it's in the year 2019. And then before that, is not coronavirus is not even a thing, and we can't think about virtual events. But Docker is came up with a very good solution of why do we back up everything and doing anybody come up. So many of the people think as a positively, somewhat no, there's a negative because we want to interact with people live on live, and I mean sharing stories, sharing our knowledge. But I think Docker is the first one to step into why do not we do a DockerCon things? And now at the end of the day, we are doing every session like Kubernetes, KubeCon or AWS reInvent. Anybody eventually move to the virtual side and just end up doing a very good thing because so many people join online and learn from each other and sharing story with each other. It's been a very good effort. And apart from your job in the dotCloud world, I'm really it's been my come a dream. However, I met with a person who started Docker in the so beginning. I think you are a few 4 or 5 guys in the dotCloud world, and when containers is not even a thing, it's a thing in the Google Cloud and other major public major property products, but it's not open source kind of a thing container. So everybody asking me what is that, how Docker is came so popular inventing this thing called container. We see that it's being there for 10 or 20 years before that, but we are not able to see that. How if Docker came up to this concept to become more popular?
I think what made Docker really popular is a coincidence between multiple things. First, there was gathering all the right concepts. You know, this whole idea that you do Docker run blah, and it's going to download that image and run it. So that was really powerful. The fact that Docker itself was really easy to install. The first versions, it was just like one binary and you just run it. And of course, today we are used to many Go programs being like that. You know, if I install Stern to view my logs on Kubernetes, or Helm, or K9s, or so many tools like that, like it's in Go, I just download the binary, done. But back then, it was a little bit of a new thing because Go was not as popular as it is today. And in particular for something as complex as a container engine, like before Docker, our own internal container engine was, I don't want to say a nightmare to install, but it was complex. I remember the whole deployment system that one of our coworkers, Ken Cochrane, he built this amazing thing to kind of package together the Python environment that we needed, some libraries and the code itself, and deploy that. We were in a scenario, you know, you always have a bootstrap, a chicken and egg problem when you need to install your container engine. What will install the container engine itself? And today, yeah, it's almost a solved problem because we have Go and we have this whole ecosystem, but back then it was much harder. So that was another element that promoted Docker. And then another thing was also timing, because Docker relies on a bunch of Linux kernel features, you know, like namespaces, cgroups, copy on write. And a few years before Docker, these things were not quite ready for prime time. In fact, in the very early days, just when I was joining dotCloud, it was just the beginning of the time where you could run custom kernels on EC2. In the very beginning, you could not. Like, you only could run the kernels that they gave you, and that was the case for virtually every hosting provider out there. So if you wanted to do some fancy container work, nope, you could not. You had to get your own servers, compile your own kernels. So we needed the way to run custom kernels. And then I remember that we went from using OpenVZ then to LXC. So there were definitely some, you know, like changing some fundamental building blocks there, using AUFS. I don't even remember if we were using AUFS in the very, very beginning or if it was something else, but that's also something that changed. Today, I don't think much folks are using AUFS anymore. It's everything about overlay, or maybe device mapper in some environments, or even ZFS or BetterFS. Like a lot of things were just not there. So, you know, if you and I could time travel to, let's say, the year 2005, knowing everything we know today, we still couldn't get Docker off the ground because we would miss the kernel, we would miss all these things, and we'd be like, okay, we have this amazing idea, but we don't have the foundations to build it. So Docker was also a lot about timing. And then there was positive reinforcement thing going on because Docker got popular. And so folks started to use, again, C groups, namespaces, AUFS, etc. a lot. So these parts of the kernel got a lot of attention. So kernel developers started to improve these features and make them more robust, which in turn got more and more folks to use Docker, and etc. You get more and more folks using that, finding bugs, fixing bugs, and then you arrive where we are today, when containers are really robust and we are still improving them. You know, we talk about this whole rootless movement. We have tools like Sysbox that lets you have some secure machine containers, you know, like privileged containers, but without the associated security risks, basically. All these things. So this continues to evolve, but at least the foundation is here, and we can run Docker and Kubernetes without having to worry about, oops, is my kernel going to explode? Which was a real problem that we had 10 years ago. You know, like just this morning, a friend was sending me this news about how on EC2 now, apparently you can get some kind of virtual serial console. I didn't read it full, but when I saw that, I was like, wow, I need that feature 10 years ago. Because 10 years ago, when we had kernel crashes on Amazon, we were just, you know, out of luck. There was nothing we could do. Like, okay, it crashed. We can't even get, you know, the kernel messages. We can't know what happened. The only thing we can do is reboot and hope that it won't happen again. So of course, that's not a good thing to do. So it's that, yeah, to wrap up, that's really everything that made Docker possible. Combining the right technology, the user experience, making that easy for developers, and timing, because the foundations could be there.
Yes, definitely. I also think that's when the Docker came up so popular, and own tool they are working on, they gave it to the community as an open source, and they can become popular and everybody talking about that. And then we see Google have their own container engine orchestration layer that they used to call Borg or Omega. Then they rewrite their own story into that, build a new entire system called Kubernetes and gave it to the community as open source. And now we are everywhere Kubernetes, and we have discussion. And I think in the IT's world, no discussion is going to be completed without we talking about the Kubernetes stuff. So can you introduce yourself, how you got introduced to Kubernetes, and why you think why it's so popular in a very shorter amount of time?
Sure. So I'm going to give you my personal interpretation, and you know, I'm not claiming that it's the only one or the true one or whatever, but this is how I perceive things. By 2014, 2015, it became obvious that we needed something to orchestrate containers, because we had Docker on a single machine that was great, but as soon as you had more than one machine, things became more complicated. How do we deal with that? How do we make that work together? So one possibility was Kubernetes, and at first I think there was a lot of doubt, maybe indecision. Is this going to work? Isn't it too complicated? And for a pretty long time, I think at least until 2016, I'm going to honestly say that I thought that Kubernetes would not work because it felt too complicated. And I think personally, I started seeing that change at the beginning of 2017, maybe. And you know, at Docker, we were kind of in a bubble in a way, because I'm going to give you an example. Mid 2016 at DockerCon, that's when we announced like Swarm mode. So which it's pretty interesting, because under the hood, Swarm mode is using pretty much the same concepts as Kubernetes. There is Raft, which is protocol that powers etcd, and then the things have different names, but you have Swarm services that correspond to Kubernetes deployments, and there is this whole reconciliation loop. So it's like taking the same idea, same concept, but with something that we thought was simpler. And when I gave the first workshop at DockerCon, like June 2016, something like that, after that workshop, I had a bunch of people telling me, oh man, that's awesome. This is leaps and bounds simpler than Kubernetes. I'm so grateful that you're doing that. So for us, it was a kind of big confirmation, and you're like, oh, we're doing the right thing. But I think we kind of were in a bubble, in the sense that we were surrounded by folks who really wanted to believe in Docker and wanted to have that simple thing that you could quickly learn, etc. And perhaps, unfortunately, things are more complicated. It's a little bit like if you're showing a car to someone and they're like, no, I don't want that whole thing with the wheel and the gas pedal and everything. I just want you to take me somewhere. And you're like, well, if you want to, drive a car, you need to learn about these things, So maybe it was something like that, where this is a problem that can't be simplified that much, and we need to get on board and learn about it. So for me, that was beginning of 2017, starting to see what we could do with it, and starting to think, well, I still don't know what's going to happen, like the folks were talking about the orchestration war, etc. We still don't know what's going to happen, but I think I need to learn that. And I took my Swarm orchestration workshop, transformed that into a Kubernetes orchestration workshop, and delivered that at the end of 2017. I think it was like the LinuxCon Open Source Summit conference, just before Docker announced Kubernetes support. So that was a big coincidence. Like at first, it was not planned at all. At first, when I told my team, hey, I'm going to do a Kubernetes workshop, they were kind of looking at me like, what? So like, no, that's okay. I think we need to do this. And indeed, it was a good idea and good timing. And at that moment, I had already, I had realized, okay, I need to take a break from work because I had this depression and burnout going on. So I was kind of preparing my landing, so to speak. I didn't want to quit the company immediately. I really wanted to take the time to put everything in order, etc. And I spent my last couple of months maybe, actually teaching Kubernetes inside Docker, like to mostly like field engineers and folks like that. So that's that. And I remember some of the reactions I got. Like some folks were really excited about it because they were seeing what we would be able to do with it. That initial complexity, when you get past that, very often, for instance, when explaining about selectors and labels, it's almost as if you could see the light going on in folks' heads and be like, wow, this is going to be awesome. You mean I can just like flip some labels and I can do whatever I want with my load balancers? That's great. So that's the thing that kind of convinced me when I saw that, teaching, sharing what I knew about Kubernetes to a bunch of my coworkers at Docker and seeing them getting so excited about the technology, that kind of convinced me, okay, that's the way to go. And I think maybe as well, and that's another side of the story, another personal theory is that we, for a few years, like 2014, 2015, we had developers being super excited about Docker and being like, oh, Docker this, Docker that, containers are awesome. And we had all the folks who were responsible for taking that to production, who are like, holy crap, how are we going to take that to production? Is this going to be, like safe and scalable, et cetera, et cetera? And in a way, I think that for them, Kubernetes was kind of almost like the big brother that comes up and says, don't worry, friend, it's going to be all right. I'm here to take all these containers to production, and together we can do this. So I think Kubernetes kind of played that card or that role as well, to be this reassuring force to be like, okay, your developers are going to play with Docker, but then we're going to run that on Kubernetes.
Yeah, yes, definitely, because I think it's a Docker and Kubernetes. Everybody would to talk about Docker. Then the next game eventually came up in the people's mind, that's called Kubernetes. Because managing a one container is one thing, and when managing millions of containers in orchestration layer and then making up to sure that all the containers are healthy and working properly all the time, and when one of the containers goes crashes, who has this responsibility to came up? So that's a Kubernetes orchestration. But to be honest with you, as I'm using Docker Swarm, and when I'm using the Docker Swarm, 90% of the cases that is fit out in my feeds, because it's so simple, so flexible, and I don't need to learn ton of new things. And really, I'm because when the Mirantis is acquiring the Docker Swarm, I'm waiting for something in the Docker Swarm ecosystem. So I want to continue using that Docker Swarm in my personal project as well. So the first question, that's wrap up to the discussion, that now our topic is today is how to manage ingresses inside Kubernetes, because Kubernetes is having so many APIs, so many objects inside it. And one of those objectives that is ingress. So can you introduce yourself? Can you introduce to our audience what ingress is and why we're gonna need it?
Sure, absolutely. So in Kubernetes, one of the complex things is how do I get traffic in the cluster? And when I say traffic here, I mean connections, not traffic, the ingress controller, because we're going to also talk about that, I guess, in a moment. So how do I get folks to connect to applications running on my cluster? And that was part of the scary things at first. It's like, wow, we have so many different concepts. You have services of type cluster IP and load balancer and node port, and communication between pods is one thing, and then communication from the outside world is something else. And that whole thing was actually, it was an argument in favor of Swarm in the early days, because we were like, look, with Swarm, it's way simpler. We don't have all this complicated stuff. Now I look at this very differently. And sometimes I talk about the Kubernetes network lasagna dish. So it's like this pasta dish with layers. And the idea behind that is that, yep, in Kubernetes, we have multiple layers. We have the pod network, we have the pod to service network, which is usually handled by kubeproxy. And then we have network policies to do firewalling. So yes, it's a lot of different things. But what's really amazing, and for me, it's a testament to the elegance of this architecture, is that you can replace these blocks independently from each other. And that's pretty awesome. So you can have your pod-to-pod communication handled by, I don't know, like Calico, and then you can have the pod-to-service network handled by kubeproxy, and then for network policies, you could use Cilium, for instance, and you could replace all of these things independently from the other ones, and that's pretty impressive that the API was cleanly separated to allow this. So yeah, it's a little bit of complexity, but in a way, it's a little bit like when that's going to be a rough comparison, but it's a little bit like when you buy a computer and you can get the graphics card and the CPU and the disk in separate components, and you can get what works best for you. So we have kind of the same kind of thing here. So then how do we get traffic, connections into the cluster? Here we have concepts at two different levels. We have layer 4, in the model with the 7 layers. So we have layer 4, which is about TCP and UDP. And for that, we use something called services. So in Kubernetes, a service is basically a way to get TCP and UDP into the cluster or inside the cluster. And then we can go to layer 7 and work with HTTP connections, and then we can do some routing, some request-based routing here. So what that means is that if I want to access, let's say, anything non-HTTP, it could be Redis, Postgres, it could be a DNS server, it could be some VoIP game server, like whatever, which is just based on TCP or UDP, I'm going to use a service. But if I want to work with HTTP traffic, I could, of course, use a service, but I could also use an ingress. And the advantage of using an ingress is that I'm going to be able to do some fancy routing. I'm going to be able to say things like, okay, so the requests going to /API will go to this bunch of containers over there running my API. The requests going to /static are going to be routed to that other bunch of containers here running maybe Nginx and serving my static assets. The requests going to anything else are going to be routed to this other set of containers that will just be dealing, with like we call that the default backend. So everything that was not matched by the other things. So that's the idea, the rough idea of an ingress is that instead of just taking TCP connections or UDP packets and sending them on my containers, no, I actually look at the requests and I can make some decisions based on the path, based on some HTTP headers, like the HTTP host. So, we can do virtual hosting. We can say, all right, the requests to something.io go to these containers, but the requests to whatever else.com will go to another set of containers, and so on and so on. So that's the idea of ingress. It's basically acknowledging, yep, HTTP today is pretty important. Thank you, Captain Obvious. And so we need something special to handle HTTP in a more advanced and complete and complex way than just TCP connections.
Yeah, because I think people are asking about that. Let's say we have an application running on the same cluster. Let's say it's a food application, and then I want some application running at some other application in the same cluster. How do I ensure that some application are running the food service and some are running the drink service? Let's say these two apps are. So instead of managing the load balancer in the cloud, this could cost up, give you some price in the cloud, but having in the Kubernetes Ingress is save you a lot of money of managing and deploying the load balancer itself. So what are the, and next question that people are asking now, let's say I have Ingress. What are the choices for me to deploy the Kubernetes Ingress, and what are the tools set I'm going to look at it when deploying the Ingress controller for Kubernetes?
So the beauty of the Kubernetes API is that for that ingress layer, so if you remember what I said earlier about this lasagna dish with the 3 layers, we could imagine that ingress is going to be like a 4th layer on top of that, and that layer can also be replaced independently from the others. In fact, sorry for the metaphor here, but it's a little bit like the ingress was some toppings on top of my lasagna, because you can have multiple ingress controllers on Kubernetes if you need to. And so I'm going to give you some examples. Like the most popular ingress is probably the Nginx one, just because it was the first one. And for many folks, Nginx meant, yeah, Nginx is performance, it's lightweight, it works great, it's awesome. Okay, go Nginx. But there is, of course, a but here. Nginx is great for many scenarios, but one thing that it didn't do super well was dynamic reconfiguration. And to give you a little anecdote, when we were running dotCloud, so before the Docker days, our front-end load balancers were Nginx. So the equivalent of our ingress controller was Nginx. And we had a little service that would basically build the Nginx configuration and restart Nginx. Each time we would scale up some service somewhere, or each time a customer would attach a new domain name to an application or deploy a new application, immediately we would regenerate the Nginx configuration and restart Nginx. Now, when you have tens of thousands of applications, hundreds of thousands of containers, your Nginx configuration ends up being something like maybe 50 megabytes. And back then, it took about a minute for Nginx to load that configuration, which, when you put things in perspective, is pretty good, because it means like building a bunch of hash tables and optimizing them. And once you've loaded the configuration, Nginx is going to be extremely fast. But still, when I was looking at the CPU utilization on the load balancers were spending more than half of their CPU just parsing configuration files. Half of the CPU was to actually route traffic, but the other half was just parsing configuration. So we're like, okay, we need to do something about this. So Samuel Alba, another early dotCloud engineer, wrote something that he called Hipachi. And so we joked that it was Apache for hipsters. And it was, you can imagine, it's a little bit something like Traefik in the early days, except that instead of being written in Go, it was written in Node.js, which at first seems like an extremely weird decision. Like, why would you write a load balancer in Node.js when it's going to serve like a lot of traffic? The main reason was that we needed something that could handle WebSockets. And back then, we're talking about like almost 10 years ago, right? Back then, WebSocket support wasn't very good outside of the Node.js ecosystem. But otherwise, that was a load balancer that you could reconfigure dynamically. In fact, it would get its entire configuration from Redis. So now, fast forward a little bit, a few years later, we have something like Traefik that comes up. And for me, that was pretty exciting, because I thought, all right, this is the first truly dynamic load balancer. It's the first load balancer where the primary source of configuration is not a configuration file. It's going to be an API. You know, like in the old days, when I have a load balancer, I'm going to write a configuration file, and then I'm going to start the load balancer. Here, the configuration file is basically, look at this API, maybe it's the Docker API or the Kubernetes API or some other kind of API. And in that API, you will find the definitions for all the front ends and all the back ends. And now you will never need to reconfigure the load balancer again, so to speak, because everything is going to be done dynamically through this API. So that was, you know, like, that was probably not the first load balancer to do that, right? I know that there was, back then, there was Nginx Plus, which was like commercial version of Nginx that had some ways to do that, kind of, except it was kind of the other way around. So you could configure Nginx with an API, but Nginx could not go and get its configuration from the API. There are probably some other products that could do that, but as far as I know, they were either not very popular or maybe internal to some companies. I'm pretty sure that Heroku had something like that, of course, for their routing layer. So Traefik for me was a pretty big revolution in the way that it was tackling that. And of course, since it was written in Go, that meant very easy deployment, that meant very good performance compared to what we could do in Node.js, good maintenance, etc., etc. So that was pretty exciting. So today, Traefik is very kind of very obviously, I want to say, it's one of the options to have an ingress controller on Kubernetes. So I mentioned Nginx, but there are many others. So we have stuff like Kong. Then you can use, for instance, envoy and then have something to configure it on the side. And if you go to virtually every single cloud provider, they are going to have their own custom ingress offering as well. For instance, if you go on AWS, they have something, so the name changed a few times, so I'm pretty sure I'm going to use the wrong name, but that's basically the AWS ALB controller or something like that, that is able to provision ALBs, application load balancers, to address, to realize ingress resources, basically. And so we have a bunch of options. And as always, when somebody asks what's the best one, the answer is it depends. Like, what are your priorities? Do you want something with incredible performance, or do you care the most about security? Do you want something that's easy to deploy and maintain? Are you running in only one cloud provider, or do you want something that's going to be easy to port across different clouds? All these questions, basically. And so to put things in perspective, if I compare Traefik with the AWS load balancer, on paper, if you look at the features and so on, it looks like, yeah, the AWS ALB controller is going to be awesome because it's going to send connections directly to the pods, and it's relying on AWS infrastructure, so this is going to scale automatically, and so on and so on. However, the complexity of setting it up correctly is fairly high. It's the kind of scenario where if you follow the documentation, and probably there is some blog post somewhere that walks you through the steps of setting it up, it's gonna take you maybe a few hours, maybe a few days, depending on how familiar you are with the AWS ecosystem. Now, when you need to transform that into a repeatable deployment, something, like maybe you're using Terraform or CloudFormation, something like that, then that's going to be a very different story. And until someone kind of packages that, so to speak, you will have to write your own Terraform configurations, your own CloudFormation templates, like especially for your environment, and that's a lot of work. And if you look a little bit deeper, like the gains that you have from that ingress controller, you can also get similar gains if you use something like Traefik or even the Nginx controller and configure it the right way, with the added benefit that if you plan to work with a different cloud provider, you will be able to do it, basically. Like if you use Traefik or the Nginx controller, then you can move from AWS to Azure to some other local cloud provider, etc.
Yes, definitely. And one thing that I also see that on the topic of community side, because these projects are doing tremendous job in their particular scenarios, and when it's up to you what's your scenario, what you are looking for, and what you want to do with that. And also I see a Traefik and Nginx and these other ALB for AWS cloud. I think for the Traefik side, I see there's a tremendous community support as well. Like they're running a global community, the local meetups, and the persons like you that's delivering workshops on this scenario. So if people caught up in surprises in any way along the way, they have this opportunity to learn from guy like you, Jerome, and other stuff in the entire ecosystem, and do a bunch of these stuff as well. And that's going to be people really like about it, because the community support is always to be a very important for all of the people as well. So in terms of Ingress controller, what are your suggestions on the best practices when we deploy the Ingress controller, what we want to do, and if we got up in a surprises when deploying Ingress controller, where to go and look out for information, troubleshooting the Kubernetes cluster, or just best production scenarios for deploying Ingress controllers?
So for me, when working with ingress controllers, one of my kind of guidelines is that I try to stick to the basic features at first, because this is one of the, if I had to say something bad about the ingress controller specification on Kubernetes, it would be maybe that it's not rich enough. I'm going to explain how and why. The ingress specification says exactly how you should configure things if you want to route different URIs, different hosts to different sets of pods, like everything I was talking about earlier. However, if you want to do something like canary deployment, send 1% of the traffic to a different set of containers, if you want to do some session affinity things, like when you set a cookie to the user, and then you can send all the subsequent requests to the same backend or the same pod, depends which level of granularity you work. But this is not part of the ingress specification. But virtually every ingress controller can do this in one way or another. And so what we end up with is that the ingress controller is going to give you a way to do that, but it's going to be a kind of custom proprietary way to do it. And it will change from one ingress controller to another. So sometimes it could be annotations, sometimes it could be with a CRD, a custom resource definition. And so for me, okay, the first step is like, let's stick to the basics. And that way, if I need to switch ingress controllers, I will be able to do so. I keep the basic features, and so if I realize something seems to be wrong, at least I can try with another ingress controller, check if it works better, and that helps me to troubleshoot, was that a problem with my ingress controller, or was that in fact a problem with my application, or maybe with DNS or whatever. And then, of course, sometimes we want to use these advanced features. Sometimes we really do need to have like canary deployments and session affinity and all kind of more advanced features. And then, yeah, but I'm kind of trying to be very careful around these, because I know that if I need to try with another ingress controller, then I will have to change the way I configure that, or maybe even the feature won't be available at all. Like, I don't remember, for instance, if the AWS ALB gives me ways to have canary deployments. It might not. I don't know, because I'm not an expert with that particular one. So that's one thing. The other thing, when I troubleshoot anything with not only ingress, but let's say ingress in the broad sense, so with the meaning of getting connections inside the cluster, what I try to do is, take a whiteboard or some paper, and I try to represent every step in my connection. Sometimes we joke about that job interview question, like, oh, explain to me what happens when I type a URL in the browser. And very often we expect folks to explain, well, there is DNS resolution, and then we connect to the thing, and there is this and that, etc. So that's exactly what I'm talking about here. Like, so when I'm having some connection issue with, like I'm trying to connect to a service running in some pod or whatever, like, all right, what is going on when I try to connect? So yes, there's going to be DNS, and then I'm connecting to maybe some front load balancer, or maybe directly to a pod running my ingress controller, I don't know. And then from that point, it's going to go to the pod running the actual service, etc., etc. So I try to show all these things. A little bit like when you are troubleshooting an IP network, you can use a tool like Traceroute, and it kind of shows you the list of routers and hops through which the packets are going. Except, unfortunately, we can't really do that as easily for an HTTP connection. It would be nice if we had a trace HTTP that would kind of show us step by step all the load balancers and so on that we go through. But no, usually we need to know what's going on, and then I will just check at every single point, is this going correctly? You know, like, is my DNS entry resolving to the right place? Okay, now I connect to that place, and I send the right headers. Is this going to the next step? And usually that will tell me what was going wrong. At some point, you know, when checking the configuration, you're like, wait a minute, this is supposed to connect to this pod on port 80. Why the hell is this talking to port 5000? What's going on here? And then you look at maybe endpoints or whatever is the pod template in the deployment YAML, like something like that. And there you go. Eventually, you find the reason for the problem.
Yeah, and also one of the few questions that people I see that in the Kubernetes distributions world, like K0s or K3s world or some other distributions, but I think K3s by default they chooses the ingress controller as a Traefik side as well. So for the last few questions, that's what are the Kubernetes distributions are, and how this fit into the Kubernetes distribution ecosystem as well, because I feel like that distros are the fastest way to implement Kubernetes API side, and if you want to do that, how you want to do that in a faster way using the Kubernetes. Can you explain what Kubernetes distros are?
Yeah, so obviously we need some kind of Kubernetes distribution or some kind of managed Kubernetes, because Kubernetes is pretty complex to deploy and set up and configure, etc. So to make a very broad parallel, it's a little bit like back in the days compiling your own Linux kernel. Okay, 20 years ago, lots of folks did recompile their kernels because very often, like that was, well, first, a long time ago, we did not have kernel modules, so you really needed to reconfigure your kernel to have the right drivers. Then we had kernel modules, but you still needed to have a kernel that at least could boot your machine. So you had different kernels for, a CSI or IDE or stuff like that. And then eventually we came to where we are today, when we have this mechanism of initial RAM disk, where you can put the modules in the initial RAM disk, and that way we can have, roughly speaking, the same kernel for everyone, or at least for all the machines running a given architecture. But all of that is now completely handled by the Linux distros. I can't remember exactly when was the last time I built my own kernel. That was probably maybe 8-ish years ago, precisely when I was at dotCloud, because we needed to have custom kernels. But other than that, I don't build custom kernels anymore. And I think for Kubernetes, it's the kind of same idea. Most of us are going to use a pre-built or even a pre-installed Kubernetes, because configuring Kubernetes is so complex, especially configuring it the right way. I mean, running Kubernetes is not that difficult. One of the workshops that I do sometimes and that I really enjoy is a thing where we run Kubernetes from scratch. So you get like an empty machine, and we just have the binaries for Kubernetes. Well, we have Docker, and we have like kubectl, we have the API server, the controller manager, the scheduler, and we're like, okay, let's run Kubernetes. And honestly, in a couple of hours, you get the cluster up and running. Well, you get no certificates, no security, the network is a hack, and but you can get Kubernetes up and running. And then you kind of get an idea of the road that you need to walk if you want all like the high availability, the security that you expect from a production grade Kubernetes setup. So that's why we need distributions, because that work is not very fun, at least for most of us. And then we have distributions for all kinds of purposes. Of course, we have all the managed Kubernetes offerings. So if you go to AWS or Google or Scaleway or OVH, etc. They all have their own Kubernetes thing, and you don't even have to worry about how do they deploy it, what's their distro. It's their own thing. They give you a Kubernetes, that's it, then you don't need to think about it. Then if you want to run Kubernetes yourself, you have this mix of distros like Docker Enterprise now is one of them, OpenShift from Red Hat, but also a lot of, I would say, installers and lots of something that is not quite a distro. Like you have a bunch of tools based on Ansible, for instance, that to install your Kubernetes cluster and maintain it with Ansible. We have Rancher, we have as you mentioned, like Key3s. We have stuff like Key3d or Kind to run a Kubernetes cluster locally in Docker containers for development purposes. We have Minikube, which is obviously not a production Kubernetes, but which is a great local development Kubernetes. So we have distros of all sizes and shapes. And I think that's great because you always can find one that will fit what you need to do.
Yeah, and one of the last few questions that I think you work for Docker and you are being the very first person, or the first person that came into the Docker. Right now, what do you think, where is Docker is moving to head? Because I think from the Kubernetes 1.20 version, we are all very, very scary and risky. What happened now? The Docker is being deprecated from the Kubernetes runtime instead of containerd. Then eventually realized that the Docker is a company that came out as they also produce this component called containerd, and that they gave it to the CNCF as an open source tool. So now I think we are very good at it because Docker is. But right now, what do you think? Where is Docker is moving, and what their directions are in terms of, because Docker Swarm is going to the Mirantis side. I think they are currently focused on the developer-friendly stuff and the cloud stuff integration with Docker CLI. So what do you think? Where is Docker currently moving now?
That's a very good question. So first, I will begin my answer by saying that I don't have access to any, confidential or whatever information. So what I'm going to say here is pure speculation on my end. I think Docker is going to really put the energy into the developer tooling. But there are some really subtle things that might be, that we might not think about that as developer tools at first, but then I'm going to give you a little example. Today we have Docker Desktop, and it's pretty amazing because when you are on Windows or on a Mac, you just install Docker Desktop and it just works, and that's pretty great. And if we compare to the hell that we had before with VirtualBox or this or that, and half of the time something would not work, and especially if you have a corporate VPN or whatever, you would have to reset a bunch of things all the time. A nightmare. So Docker Desktop is pretty incredible, and even if we still have some folks complaining sometimes like, oh, it's using all my CPU, etc., you're like, yeah, but it's still using a fraction of what it would have taken if you had done things the old way. Like you have 10 containers and it's taking a bunch of CPU, but if you had done that the old way today, like, you would have 10 VMs and then look at your CPU and let's talk again. So Docker Desktop, for instance, is based on some technology that was kind of unexpected. At some point, Docker started to work with this whole team based in Cambridge and working on unikernels. And everybody was like, ooh, what are we going to do with unikernels? And we're talking about this whole, hey, you put the code and then the kernel together, and that gives you this really small kernel, etc. Yes, but unikernels, it's exciting and promising, but also lots of operational issues, etc. Well, that was not the point. The point is that that team is the team that shipped Docker Desktop, because the technology that powers unikernels is maybe not the same, but very, very close to the technology that makes something like Docker Desktop possible. And that's a kind of like, wow, what's the connection there? On the one hand, you have some really low level kind of hardcore kernel stuff. On the other, you have this very convenient desktop application. What's the connection? Well, the connection is within that whole stack of things, like how do we run VMs in a way that they're running as normal programs, etc., etc. Can't really go into a deep explanation about that, but that was a kind of an unexpected benefit, an unexpected result. And I think that there are some really interesting moves that Docker can do there again. For instance, support for multiple architectures. I think it's getting like a more and more important things these days. Like for a really long time, Docker only officially supported like Intel Linux 64 bits. And of course, from the very beginning, we had folks running Docker on Raspberry Pis because why not? And we even had contests of like, how many containers can you fit on a Raspberry Pi? And I think the answer was like 2,300, which was like mind-blowing. And then we had support for Windows and then for ARM platforms. And now ARM platforms are not just, you know, a bunch of folks running Docker on Raspberry Pis because it's fun. Now it's a bunch of folks running Kubernetes on Raspberry Pis because it's fun, but it's also a bunch of folks running containers and applications on ARM servers because it's cheap. And at scale, cheap is something interesting because you save a lot of money because you need less instances or instances that are cheaper, but suddenly you're running on ARM, and that's a whole new challenge there. And of course, we have the new Apple M1 like that came out like recently, and that's also ARM based, and that's a different platform. And pretty quickly, Docker was running there, which is not very surprising when you know how Docker Desktop works, but that's still a pretty good thing. And I think Docker might be able to do interesting things here. Maybe, I don't know, maybe giving us a way so that whether I'm working, you know, like a big thing was giving me a way to work with containers, whether I'm on Linux, Mac, or Windows. So maybe the next thing is going to be giving me a way to work on ARM and Intel CPUs, regardless of my local architecture. You know, like the same way that 5 years ago, okay, now I have a way to build a Linux container on my Mac. Now maybe tomorrow the thing is I'm going to have a really nice way to build an ARM container to run on my AWS or whatever ARM-based servers, even though locally I may or may not use an ARM CPU. So that's one thing that could happen. And generally speaking, developer tooling, Kubernetes is an amazing platform for production, but it sucks terribly for development. We still don't have the equivalent of Docker Compose. We still don't have the equivalent of a thing where I can do that demo that I was doing, what, 6, maybe almost 7 years ago, when you do like, okay, clone that repo, run one command, and 5 minutes later, we've built a bunch of containers, everything is running, and that works on any machine, anywhere. We still don't have that with Kubernetes. I don't have like, you know, the 2 commands that I can run and that will build and run my app. Sure, I can apply some YAML and that's going to start a bunch of deployment services, Ingress, whatever, but I still need something somewhere to build my images. And that's when things become very complicated and involved. So I think Kubernetes is still missing that. And who knows, perhaps Docker is going to do something very interesting in that space too.
Yes, definitely. Because I've seen there's some very good announcement coming on for the last year that they changes some kind of kernel features. It came up with the integration with the cloud provider, like you can use a Docker CLI command to deploy container directly to the Azure, AWS, DigitalOcean, and other cloud platform as well. And they have a Apple chip sports, and they continuously evolving and optimizes the development flow inside Docker. They have integration with Scenic tool that we have for it's scanning their images. So they've done a tremendous job for development side as well. And I hope to see Mirantis does something for Docker Swarm as well in this year. Came up some features that they're coming up, because it's a very flexible, awesome tool. Folks, when I tell you, folks like me, when I use this in production, because very cheaper, we don't want to understand so many stuff, is to remove a lot of the complexity. And when you use a one command, it's everything built for you. It's just awesome too. So Jerome, it's with the because we are out of time right now. So where folks, when I search you on the internet, and if you want to learn from more, where you want to see you after this talk?
You mean where will I be? Where can people find about what I'm doing? I have two things. So I usually talk a lot about containers and other topics on Twitter, where I'm Petazzoni, Jpetazzo. And I usually announce my upcoming trainings on container.training. It's just like container.training. Since we have less conferences these days, there are less public trainings announced here, but I also do a lot of private training. So if folks want me to deliver a private custom training for them on Docker or Kubernetes, they should absolutely reach out, and I'll be happy to help them.
And also, what your extracurricular activities are, mean like when you're not talking about containers or Kubernetes or Docker, what you're gonna do? I see you have some you love for some musical instrument as well.
Yeah, when I'm not computering, music is a pretty big thing for me, and I like playing many instruments. A little bit like, when you program, you often end up writing with multiple languages, and so for me, instruments are kind of the same thing. The first one, it's really hard to learn, it's difficult. The second one, it's still hard, but at least you know the names of the notes, and you can maybe read music or whatever. And from the third instrument, things get easier and easier. So yeah, for me, that's a thing. And then of course, some instruments are very difficult. The same way that if you want to do, I don't know, like assembly language or Rust, then when you play music, at some point there is maybe the violin or or something like that, which is going to be incredibly difficult and require a decade of really thorough practice to be nice to play. But there are also many instruments that are less demanding. So yeah, I like to play the keyboards, the cello, even though I haven't played it in a long time now, the guitar, the bass. I even have a theremin somewhere. So yeah.
Thank you very much, Jerome. I'm really talking about, it's been a very good, entertaining session for me, because I had this opportunity to sit with the person who came into the Docker and container was so early in the setup, when container is not even a thing, and Docker is used to be known as dotCloud, and we'll learn so many great things, so many great. I have a very good opportunity to learn so many great things from this talk from you, and hopefully everybody who watched that later in the YouTube channel, our Cloud Native Islamabad, you can enjoy this talk and learn so many great stuff from Jerome Petazzoni. And also, we are running a Traefik Islamabad meetup as well, and our first talk is going to be what their Ingress controller, what Kubernetes and what Docker are. And meanwhile, I am chatting with Jérôme as well. Hopefully we can do another session on Kubernetes Ingress or some webinar kind of stuff. So if you want to keep up to date on it, go ahead into the meetup.com and search for Traefik Islamabad meetup. and join that, and hopefully we can catch up with Jerome Petazzoni again, and he showed us how to run Kubernetes and how to manage ingresses and other cool kind of stuff. But thank you very much, Jerome. You share your time with us, and hope I can catch up you again in the future. And thank you very much.
Thanks for having me. Bye-bye.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, container containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.